Right, let's go into energy. Energy, by definition, a very simple definition, is the ability to make things move. So as long as any object who can make things move, that object has got energy. So, for example, me, I can lift this up, so actually I have energy. Energy has got basically two types: potential energy and kinetic energy. Let's talk about kinetic energy first. Kinetic energy is any energy that is due to speed. The higher the speed, the higher the kinetic energy. The bigger the mass with the same speed will have bigger kinetic energy. So let's try this. So this one now with a low speed, it cannot make things move so effectively. But if it has got a high speed, this object, then it can make things move better. So slow speed, low kinetic energy; high speed, high kinetic energy. Another factor that affects kinetic energy will be the mass of the object. For the same amount of speed, right, the object with a higher mass will have higher kinetic energy, means it can make things move further. Let's try. Okay, to conduct this particular experiment, we need two objects. One is going to drop down from the top, the other one will be placed at the bottom of the ramp. So when we drop down, you push this object, we call this A and B. You push B away, and then we'll decide who has got a higher kinetic energy based on the distance moved. So let's try object A with no mass on it, which means that it's lighter. We have a marker here, so every time I'll put it at the same place and drop. So this is how far object B moved, and this is the distance moved. Now, what I'm going to do now is to add heavy mass here. So now A has got a higher mass, put from the same place. So when an object has a higher mass, when it's dropped down from the same distance, same height, it should have the same speed when you go down to the ramp. So if they have the same speed but different mass, so what's going to be the difference? So we can see that now object B is being pushed further, which means object A has a higher kinetic energy compared to the previous experiment because of this extra mass. Okay, after kinetic energy, then we talk about potential energy. Potential energy is stored energy, meaning it's not shown yet, but it's ready, ever ready to produce a kinetic energy or to make things move. So potential energy, we have three types: gravitational potential energy, elastic potential energy, and chemical potential energy. Let's illustrate on gravitational potential energy first. It is related to mass and height. If the mass increases, gravitational potential energy increases. If the height increases, gravitational potential energy increases. Okay, so this is trial 1 with lower height. Okay, then now trial 2, when the height increases, we want to see whether the gravitational potential energy increases, so that you increase the kinetic energy as it hit. Hopefully it can penetrate through this piece of paper into the container. Okay, next, what we are going to do is to investigate gravitational potential energy again, but this time it is talking about the mass. So we try to make sure that the height is the same, then we will drop down and see what happens. So let's use this as the marker. So this is the height, right? And then we let go. Okay, so it doesn't penetrate. And now we will add water in to increase the mass, and we'll see what happens. Okay, part 2. Now we have filled this bottle up with water, and with the same height, we want to see that the gravitational potential energy increase so that it can convert to more kinetic energy and make the paper move. So it's the same height now. Okay. Gravitational potential energy, which is affected by the mass and height. As the mass increase, gravitational potential energy increase, or whereas the height increase, gravitational potential energy increase. Now we go to elastic potential energy. Now elastic potential energy is affected by these two: the material and the amount of deformation. Deformation can be a compression, can be a bend, can be a extension. So it depends on how much it is being deformed. So elastic potential energy, let's show one. This. So basically it has got the ability to stretch out and push things, because before that I have rolled it and I changed the shape. So this is a kind of elastic potential energy. And we have some more. For example, this. Now there's a rubber band here. If we stretch it, it's an extension. So elastic potential energy is affected by the stretching of this material. Then it can convert to kinetic energy and make things move. So let's try. So what we have here will be a rubber band. Put your hand in like you shoot a rubber band. Then when your finger goes into this hole and shoot. Right? So I stretch a little bit. It can go this much. And if I stretch a little bit more, then it should be faster and it can go further. Okay, there are other interesting toy, potato chip, that can show elastic potential energy. So do you want some? So what we have here is spring. There are spring inside, and it's being compressed inside this container. So once we release it, it will jump out, and that will be your kinetic energy. So the effect that you see as an energy is normally a movement, and potential energy, let's go back, is a stored energy, is stored here, not used yet. The moment we release, it can give off its kinetic energy. Okay. Right, there are other things. Again, spring. So spring is shown here. Compress it, and then it's stopped there. After a while, you release and jump. Let's try again. Add a little bit of water to make it more, the suction bigger. So that's a show of kinetic energy based on the potential, elastic potential energy. Okay, we have other energy, other equipment to show elastic potential energy, and a wind up toy is a very good example. So we wind up, inside there's a spring, and then you should be able to see movements here, and this movement creates sound. Okay, this is a close-up view of this musical box. Basically, elastic potential energy is stored here. When I release, it will start turning and create a kinetic energy. Then this kinetic energy will make this roller move, and this roller will force this pin to move up and down, creating vibration, and hence you can hear sound. Okay, by the way, sound is also a form of energy. Let's see. Okay, to prove that sound is also a form of energy, what we have here is two drums. One drum, two drums. Now this drum, we have a ping pong ball tied to the center by a string. Right? Then as we know, sound is a form of energy. Energy can make things move. So what we are going to do is create sound here and see what happened to the ping pong ball. Let's go. Can you see? Can you see the ball moving? So the kinetic energy of this drum force the air here to move, and that is sound. And this sound pushes this drum skin and make the ping pong ball jumps. So the ping pong ball is jumping. This shows that it has energy, and the energy comes from the sound which is traveling from this drum to that drum. Next, we'll talk about the last potential energy, chemical potential energy. A chemical process is an irreversible process, which means it cannot go back to its original form. For example, if I eat a hamburger, go through my body, then there will be a chemical process here. The hamburger will not come out from here. It's going to be sheet, which means it's a different form altogether. And what happened to the hamburger? All the nutrients will go into my body as an energy, and therefore I can make things move. So food is a form of chemical potential energy. And then other potential energy will be battery, like what we have here, right? Chemical potential energy. And let's see what battery can do to make things work. So this is a battery box with 4 batteries connected in series. So now with wires, we can actually produce light, which is a form of energy. Okay. So what happened here is chemical potential energy actually turns into electrical energy, and that flows into the wire, and then it turns into heat and light energy that goes that produced by this bulb. Heat and light, electrical, they are all considered as energy. Okay, since we talk about electrical energy, now we come to this equipment called windpulse. This windpulse can convert kinetic energy to electrical energy. Let me show you. Right. So this is similar to lightning, but take note that whatever you see, the flash of light that goes through, that is not electrical energy. That one is light energy. Electrical energy we can't see. We know that something has flowed through this called electrical energy, but as it flows through, it heats up the air and it produces light and it produces sound. So that is light and sound, not electrical energy. Okay, so electrical energy is here. It can make things move. How to show? What I will need is maybe a little ping pong ball. Put near here, then we start to charge up, produce electrical energy, and see what happens to the ping pong ball. Can you see the ping pong ball is moving? Yeah. Now you need not know why it moves. This one you'll learn in secondary 4. But basically, electrical energy can make things move. It's a form of energy. Okay, now this is in the market they call this the hand boiler. It's to show that heat can cause movement. So what we have here is basically this red liquid is alcohol, and there's some gas here. So how can heat make things move? Basically, it's by expansion of gas. So my hand has got heat. My body is about 36 degrees Celsius. Now this environment in the aircon room, most probably the temperature now is about 28, 27 degrees Celsius. So this is cold, my hand is hot, heat will flow from high temperature region to low temperature region, and let's see what happened. Now, can you see the other side, the liquid is, the level of liquid rises, and here got no more liquid. Why? Because the gas here expand, it pushes the liquid from this container to the other container, right? If I put my hand here, the heat goes into this gas here will expand and push the liquid to the other side. Okay, does it move? Yes. So there must be a form of energy involved, and this energy we call it heat energy. Right. This equipment is to show you that kinetic energy can convert to heat. You should have learned force. Friction can cause heat, friction between this surface and this surface. And what create that friction is actually the kinetic energy. Let's see. Right, you can see spark, there's heat produced, right? My hand need to move, so what I'm doing is converting kinetic energy to heat energy and also some form of light energy. Okay, so we have talked about solar energy, which is light energy, we talk about sound, we talk about electrical, we talk about heat, now wind. Now in many countries, they don't use fuel like us to give you all the electrical supply. So they use natural resources, and what we have here is we can call this a windmill. So country with plenty of wind blowing, what they do is they place this thing on top of their roof, and when the wind blow, it will convert through generator to electrical energy and then to heat and light energy. Let's see. Can you see the light here? When there's movement, there's light. When there's no movement or not enough movement, then there isn't any light. So what happened here is kinetic energy goes through this thing called a generator and to produce electrical energy along the wire. Then when a wire reach this electrical energy reach this light bulb, you convert to heat and light here. So this is windmill to produce electricity. Basically, this is known as renewable energy, and what is renewable energy is energy that cannot be used up in the near future. Another form of renewable energy will be it comes from the hydroelectric plant. So what they do is they make sure that the water is high. They build a dam to block the water from a river, and the river will rise, and then when they let go, the water will flow down. Then this water will convert from gravitational potential energy to kinetic energy, and then you will produce electricity through this generator also. Let's see. So I'll let the water go maximum. So they will place this generator right below so that the water is fast, and you will get light from here. Now what happens if this generator is placed higher, the water is not fast enough, then you will not get enough electrical energy. So when it's low, more gravitational potential energy converts to kinetic energy, and you see that this is brighter, more energy is being converted. High to high. Okay, this is a toy. It contains two bags inside. One is vinegar, the other one will be baking powder, and these are all chemicals. When you put them together, there will be a chemical reaction. Then you will produce a lot of carbon dioxide, and this carbon dioxide will push and break this bag and create a kinetic energy for it to jump. So let's see. So chemical potential energy inside, break it, And let's see how fast it can convert to kinetic energy, and hence gravitational potential energy and sound. Happy birthday to you.